I'm going to take the same method I just used here, but we have to be a little more careful because this graph is just a little more tricky than the previous one. Okay, so thank you. We've applied some constants here. I'm going to have a shift, bit of a stretch. What's happening? When you've got your set of axes there, okay. The first thing I'm going to put on there, I think the easiest feature to recognize is that there's an asymptote in here. Is it vertical or horizontal from this denominator? It's vertical. Okay, we'll talk about horizontal and oblique asymptotes, which are their own class of asymptotes in a minute. But for now, recognize that essentially what you're saying here is because it's on the denominator, x, which is a horizontal value, right? X can never be equal to 2, and that thing makes sense. Okay, and x of course is along here, so if I pop -2 there, right, there's where I'm going to put my asymptote. Okay, so far so good, right? Now, after that, I can think about the horizontal asymptote, which as it happens is going to be the same. Okay. And then, how is this different from, say, if the 3 wasn't there? If it was just a 1. What's the difference between having a 1 there and a 3 there? It's just going to be, well, depending on which way you think about it, it'll be stretched this way, or it'll be squashed this way, okay? There's a vertical, like if I put in values, they're going to be 3 times higher than they would have been if there was just a 1 there, okay? So when I draw my graph, I'm probably going to need to have some intercepts in here to represent, because like, you know, this shape could just as well be 3 on x as it is 1 on x, depending on where I put some values. Like if I say that spot there is 1, 1, then I'm on 1 on x. But if I say it's 1, 3, which is perfectly fine, it's a completely different graph now, okay? So let's put some intercepts on here. I'm not going to have any x-intercepts here, but what's my y-intercept going to be? Think about it. How do I get a y-intercept? I say x equals 0, right? X equals 0. So when I pop x equals 0 into here, I get 3 over 0 plus 2, which is 3 over 2, 1.5. Okay. So if this is -2, I'll try to keep my scale reasonably consistent. 1.5 is going to be somewhere up there. Okay, I'm not going quite as far. And that's kind of enough, like, because over here I'm actually not going to cross any intercepts, that's going to be enough to actually draw this thing. Like so. Okay, and I'm going to have the opposite shape over here. Okay, that's nice. In that case over there, I was comparing a rational function, a hyperbola, with a horizontal line, 2. But this time things are more complicated because I'm comparing it with another linear function, okay? So what does y equals x, what would that look like on this graph? Well, we've seen this before. This is just going to be a line straight through the origin, right? So let's go ahead and draw that in. Okay. So now we have a look at this thing. What are we after? If you have another color there, that will be immensely helpful. If you don't, you can try and do like shading or something like that to represent this. I'm looking for, again, just like there, when one particular thing is less than or equal to another thing, right? So that's the rational function. When is it less than or equal to my linear function? When's my hyperbola less than or equal to my straight line? Okay. So you can look, you can see the points where it are. Let's go from left to right, okay? Where is the first point that you can see the rational function beneath the linear function? Where do we get there? Where do we get there? It's there, isn't it? That's the first spot where the rational function crosses over the linear function and goes underneath. Okay, so I'm just going to mark that in. Right there. That part satisfies the inequality. Okay. How about the boundary? Does the boundary satisfy?
Yeah.
It does, doesn't it? Because I have a boundary here. And of course, if it was just less than, exclusive, then I'd have a hollow circle there, but I don't. I've got a filled circle. Okay? Yeah.
Isn't it a bit painful finding like the intercepts, like the coordinates?
We'll find out in a second. For now, I'm just interested in where are the places, generally speaking, where I'm going to have solutions to this, and then I'll work out the exact values shortly. Okay? It's worth saying though, if the values are painful to find through one method, they will be painful to find whichever method you use, okay? As you'll see in a second. These ones happen to be easy, and all three approaches that I'm about to show you, you will find that they are easy, okay? Because of the way the function's been crafted. Okay, now, let's keep going here. We said that's the first point where it's okay, and it keeps going, but it doesn't go on forever, does it? It stops at a point. There's a point where, after that, I'm no longer satisfying the inequality. Where does it stop? It's -2, right? -2. Because after that point, right, because there's a discontinuity in the hyperbola, things flip over. If I go just to the right of -2, now my hyperbola is way above my linear function. Okay? So I have to stop there, and I have to say, well, okay, I'm no longer satisfying the inequality. But then as I keep going from left to right, it happens again. Bam, right there. Okay? Does that make sense? So here I have another portion of the hyperbola which is beneath the linear function. Okay. So there you go. Now I have two regions and I just need to describe them. Okay. So being that, remember, this is a 2D illustration to help us answer a 1D question. This is just in X's, there are no Y's. Okay. I'm now going to compare this response to the X-axis. That's where the real answer is, yeah? The X's. So I've got this dot, 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 filled circle, okay? And then I'm going to go from left to right until, as we just discussed, I hit the asymptote. And then what happens? Do I have another filled circle? Because I'm inclusive, right?
No, it's like
Why don't I?
because you can't include.
Okay, it's an asymptote. I can't actually get there, right? I can get infinitesimally close, but I can't get to -2 itself, okay? So that's why there's this sort of asymmetrical thing happening on this inequality. Okay, so I'll find out what those values are in a second. And then, of course, over here, same deal. From this value, but this time I do go on forever, okay? So now I know what points I have to describe. I just need to find out their values. I already have this one, okay? These two values here, how am I going to find out what they are? Those 2 points, right, they come from where this hyperbola intersects with the line, right? How do I find points of intersection? I just solve. Now, be careful. I don't need to solve simultaneously, right? Because these things on my diagram, they are simultaneous, right? It's just when the hyperbola, which is given by that, is equal to the straight line, which is equal to this. I just have to solve that. That's easy, okay? Now, keep in mind, because this, finding the points of intersection, it's just an equation. It's just an equation, okay? I don't worry about having to multiply by a square or anything like that. I can just multiply through by x plus 2 so long as x plus x itself isn't -2. Because if I multiply through by x plus 2, I'll be, in this case, right, I'll be multiplying through by 0, which I can't do. So anyhow, what am I going to get? X squared plus 2x. Yeah, I'll multiply through by x plus 2. This is very simple. Once I bring everything over to one side to factorize, what's the factorization?
X plus 3 minus 1.
Plus 3, x minus 1. That's nice and easy. Great. Mark that, by the way. Mark that pair of factors because they're going to come up again. Right? So now, what are my values? -3 or 1. Now, I couldn't have gotten out a ruler and saw that, but you can see that my graph is at least in the right ballpark, right? -3, yeah, that does look like that, right? Roughly. And 1, yeah, that's consistent, okay? So off of this, I can now state my solution to the inequality, right? Therefore, this inequality is satisfied when I'm between these two values, -3 inclusive, because our diagram told us so, and exclusive to -2, or x is greater than or equal to 1.